action potential in the SAW node. The node acts like a heart's natural pacemaker. To create an action potential, it involves a special mix of chemicals and electricity. Initially, sodium ions rush into the SAW node cells, making them more positive. Then the potassium ions leave, making the cells more then negative again. This quick change from positive to negative creates an electrical signal which triggers our heartbeat. So then we're gonna talk about the conduction system of the heart. The heart has a built-in system for spreading this electrical signal. So after the SAW node sends the signal, it travels through the atria, causing them to contract. Then the signal then moves to the AV, atrioventricular, which acts like a gateway, slowing down the signal just briefly. Then it goes into the bundle of His and then splits into the right and left bundle branches, conducting the signals to the ventricles. Then this coordinated sequence of all these steps make the heartbeat beat in the right parts, atria, then the ventricles. Then conduction system of an electrical cardiogram, ECG or EKG. The electrical cardiogram is a test that measures the heart electrical activity. It consists of the three main waves: P wave, that reflects the electrical activity when the atria contract, then the QRS complex. This represents the electrical activity as the ventricles contract. Then we're gonna have T wave. This shows the electrical recovery of the ventricles. Then the ECG traces the path of the electrical signals, matching them to each of the waves. It helps the doctors diagnose their patients to see the electrical activity is normally regular for their patients. So the SAW node creates an electrical signal that tells your heart to beat. Then the heart's conduction system helps spread the signal properly. Then the ECG or AKG record the electrical changes, and each wave on the ECG correspond to a different part of the heart, different electric part of the heart, which helps the doctors keep tabs on your heart's health for their patients to know exactly what's going on. So each of those waves has a particular job. So now I'm going to show on page 703, there's the pacemaker potential and the action potential of the SA node, which is this one right here. All right, so firstly, we're gonna have the bottom is time in seconds, and inside will be membrane potential in MV. So we see that it starts at -60 right there. And then it will depolarize going up. Then here you will have both of the inflow and the outflow. Then it will repolarize going down. Then right here we see that we have a threshold and the pacemaker potential. So the threshold will be this segment pretty much, and then for the pacemaker potential, you see it's there, so it would be from -40 to -60. So -40 to -60 will be the pacemaker potential. Then we'll go to the action potential. You see here the highest one there. So the highest that it will reach will be 0, and it will start from the -40, which is where it would get the action potential, from the -40 to 0. Then we're gonna have here the conduction system of the heart. So what the main important thing for me when I see this is the plateau, because as we can tell that the other one does not have a plateau. So the reason why the heart has one is because the plateau gives us a brief couple of seconds, or not even, I would say, to fill our heart with blood, to give us time. Because if not, then how would that happen? It would be way too fast. We wouldn't our heart wouldn't even be able to receive any blood, because that takes probably, you know, not a long time, but it has to be quick, but it still needs to happen. So that's why we will have this plateau right here. And then, like I said, this is a depolarization, then the plateau, then the repolarization. So yeah, definitely important. That plateau is what keeps us alive.